Welcome to the AME Food Testing Show. Today's topic, real-time detection of pathogens using customized nanoparticle biosensors with Fred Byerlein, MBA, and Hong-Yau Mei, Ph.D. Mr. Beyerlein has over 30 years of experience in early-stage enterprise development, early and mid-stage product and market strategy, financial systems, and overall business strategy. Mr. Beyerlein currently serves as the CEO of nanoRETE, Inc., a biosensor development company focused on pathogen and toxin detection within the food, safety, and supply markets. Mr. Beyerlein received his MBA in economics and finance from Fordham University. Dr. Mei received his Ph.D. from Columbia University, followed by an NIH-postdoctoral fellowship at the University of California and an Executive MBA from Michigan State University. He's held positions at Pfizer and Parke-Davis Pharmaceuticals, Rubicon Genomics, and Neurointervention Technologies. Dr. Mei has over 60 patents and publications and abstracts. Now, welcome with me, Fred Byerlein and Dr. Hong-Yau Mei. Well, gentlemen, let's begin. What are human pathogens such as anthrax, E. coli, salmonella, and tuberculosis?
Well, I think the human pathogens that nanoRETE and nanoRETE that we're particularly interested in are E. coli, especially the pathogenic strains such as O157H7, and salmonella, and in particular salmonella enteritis. On top of that, we're also interested in diphtheria. And as far as the toxins that we're interested in targeting, as you pointed out, anthrax and the some chemokines and cytokines associated with the tuberculosis infection.
Very good. Gentlemen, what are the traditional methods of the detection for these pathogens?
I think broadly speaking, there are a couple of well-established screening methods for pathogen detection. Traditionally, there's a cell culturing method that's being broadly used and well accepted. However, I need to point it out that that type of traditional method usually involves labor and the costs that are more advanced than the current technology can offer. There's also another method that's being broadly used that are associated with the PCR base, and that is a polymerase chain reaction. And at the same time, it also requires longer time and sophisticated personnel as well as laboratory setup to do them.
Very good, gentlemen. And, you know, as you look at your experience in these traditional methods, is there a need for a faster testing methodology and instrumentation?
Well, before we embarked on this adventure called nanoRETE, we did an awful lot of market understanding. We had what we felt was a good technology base that we were ready to license from Michigan State University. But before doing so, we went around and it was also in combination with the work I had done at the Global Food Protection Institute, of where I'm an advisor and a member of their advisory board. That what the people were telling us on a continuum was, with the new rules that are coming and being proposed, with the concept of test and hold as opposed to test and release, and for some of the global food safety initiatives that are being proposed, and that actually people like Walmart and Costco are already very active in. The folks want to know, they want to be able to screen at the source or at the point of contamination, or before that foodstuffs enter the chain, that they want to know, do we have an issue here, or can we release it, and can we release it a high degree of confidence that it's clear and free of the pathogens that they're screening for. So I would say that given the global food supply chain, given that most of what we're talking about in today's world is perishable, and given that time is money for the industry on an overall basis, I'd say if you can't come up with a way to do it a lot faster than current practice, then we have a serious economic impact to the food chain, not just in the United States, but in all countries. And it'll be an economic impact.
So your answer is yes, we need something faster than waiting 2 to 4 days or longer for results prior to release of these products. Is that correct?
That's absolutely correct, and it's to a T. And we've talked to a very broad group of people. We've talked to the folks in the meat processing industries where they're moving it across borders. We've talked to some esoteric areas that people don't realize are potential problem areas. For instance, almonds, what's called soft fruits, certainly peanuts. Everybody knows about the recall issues there. It was also true in green leafy vegetables, and in at the very top of the list in terms of potential damage was things like bean sprouts. So we looked at a broad range of applications, and to a T, they said it would be wonderful if we could screen. We would know if it came up positive, then you can always do confirmatory testing. But if it's clean, then we want to know that we can release it, and the likes of the Walmarts and the Costcos and the Myers of the world will accept it.
Very good. Gentlemen, your company has developed a barcode technology. Can you explain that for us?
Well, just imagine that if one is in a supermarket, as you're picking up an item from a shelf, and each item is uniquely barcoded, and therefore when you go to the checkout point and you can do a scan, and immediately a particular barcode corresponds to a specific item that you're purchasing. It will be the same idea that we apply here, that at nanoRETE we develop a biobarcode technology that can transforming a particular biological event into a electrical signal that is unique to that biological event. So that is, in a nutshell, how the biobarcode technology works. In particular, what we're working on here is to apply nanoparticle-based technology to serve as a label for transforming a particular target recognition event into a electrical chemical signal. So that is I think is a general description of the biobarcode technology that we develop here. What I would also add to that is that the biobarcode technologies that we develop is a platform technology that can apply to any particular pathogen targets using the same platform. The differential factor here is that we can use a particular label for a particular pathogen. So, for example, we can use a nanoparticle that is a cadmium-based, a metal ions that is a heavy metal exists in the periodic table that you can find, and that can represent the presence or absence of, for example, E. coli 0157H7. And at the same time, we can also use a different metal ion, such as lead, that you can find from a periodic table, that can represent the presence or absence of another pathogen, such as Salmonella. So by using these unique barcodes, we will be able to detect and distinguish the presence or absence of any human pathogens existed in a food matrix.
Now, if you want to take that a step further and kind of segue into the concept of multiplexing, it's these barcodes that allow you the ability to do a multiplexing event. For instance, if in a specific food matrix you wanted to test for Salmonella enteritidis and E. coli 015787, then you would conjugate your two different biobarcodes so that they would respond to the presence or lack thereof, and allow you to test in a single sample capability for more than one pathogen at a time.
So, gentlemen, help me understand. So the sample is taken and placed into your detection media, and then your instrument is turned on, and then the detection of presence or absence or even quantitation is then evaluated and can also have multiple tests with one sample. Is that correct?
In a simplified view, that's absolutely correct. There is some sample preparation, of course, on the front end, where you have to reduce the sample size or an extraction event, but then in essence your summary is correct.
Very good. As part of your technology, you're employing square wave anodic stripping voltammetry. Can you pronounce that correctly for me, or SWASB?
Sure. Yeah, it's a square wave anodic stripping voltammetry. And
very good.
That is the technology that's being invented probably in the early 1920s, and it was actually awarded for a Nobel Prize for the discovery of that. And a little bit of historical background on that. This was really invented primarily in the past for screening heavy metal ions, a contamination in groundwater or other sources. And this is a very sensitive and highly specific analytical tool that was used in the past for, as I mentioned, for detecting heavy metal contaminations in the environmental samples. And at nanoRETE, we are taking advantage of this technology in screening pathogens, primarily using the advantages and of this technology in the area of their sensitivity, selectivity, and also the ease of use. Because since this technology was really invented almost 90 years or a decade ago, it's very robust because of the nature of this technology. And this is really what we at nanoRETE are trying to take advantage, is using a well-established technology, but in a very unique type of applications in human pathogens screening for a complex food matrices.
So what we're trying to do under this concept is very simply change a biological event to a chemical event to a electrical event.
Fascinating. Gentlemen, what is the turnaround time from the collection of the sample to the reporting of the result?
Well,
I understand it's about an hour.
Correct. And that is really from the standpoint of running the assay that's being developed at nanoRETE. So if you have a sample that's being collected and treat it so that it's in a suitable format. And once you introduce that sample into our assay, into our instrumentation, we anticipate that it will take an hour or less of time to get the results to indicating whether there is any contamination of a particular pathogen or not.
We visualize that the entire process would be somewhere between 2 and 4 hours beginning to end. In other words, we, after talking to the field, the users, we discovered that the magical number is to find a point of use test. It would be best served if it was in what they call a half shift time. That's 4 hours. So that's our target window of opportunity.
Very good. Gentlemen, in our audience of 54,000, there are food production managers, food quality managers, food safety managers, and food security managers. Can you discuss with this audience the price advantages of these new technologies as compared to the more traditional tests that they're used to, like taking a sample and running it off to a lab for a culture test?
Again, this comes back to original question in the earlier of this interview. It really comes down to the cost in the labor and the cost of the materials that's used in running a particular assay. So on the labor part, the traditional screening methodologies usually takes anywhere from a day to 3 days or even longer. So there is a significant labor cost for running the assays that need to use very skillful technicians. So that's the labor cost that we can certainly reduce using our assay, because as we pointed out, our assay can be run with the limited resources and not very well skilled technicians in the field. So we consider that as a major cost saving there. On the other hand, from the reagent standpoint, we also use very limited reagents and that are in the range of anywhere from $5 to $10 per assay. So we believe that is also a major cost saving compared to other methods such as culturing, plating, or PCR, which normally runs anywhere from $25 to $40 per assay.
And then again, you would also have to add on to that the what they call the cost of more than half shift, or the cost of test and hold, especially to perishables. So we feel that we have a significant advantage.
Very good. Gentlemen, can you just review for us briefly the entire scope of your offering, which is, what are you testing for? How does it compare against traditional methods? How does the science offer particular advantages to food production officers? And finally, this price advantage, and when will you have it ready? I've been involved in technology for about 25 years, and when I finally see the lights turn on my client, I always ask that fatal question, Andy, when can I get it?
Actually, they're all good questions, and I think from our perspective, there are a lot of issues out there in terms of pathogens, less so in terms of high priority toxins, but we've chosen to focus in on the E. coli family, what's neatly called the STEC group, STEC, and also Salmonella enteritidis and Salmonella in some of the more generic forms. Now, why did we choose those? We chose those because our identified collaborators that we're working with now, and also the people who will be doing our field validations for us and with us, that suits their market needs, and these are large purveyors of everything from processed eggs all the way down to fruits and nuts, to large consumers such as the Walmarts or the Myers or the Costco's of the world. So we're sensitive to their needs. The name of the game is it has to be rapid. That means it has to be half shift, or as I've said, 4 hours, less than. It has to be cost effective. That means it cannot tie up a lot of money in capital dollars. You can't have a $260,000 machine necessary to run it with two master's or Ph.D. level people. It means that the reagent cost has to be certainly less than $40 a test, because there are tens of thousands, if not hundreds of thousands of tests done each year. I think in the U.S. alone there's 144 million done. Back in 2008 was the last time the numbers were collected. So that tells you there's a lot of dollars tied up there. So we've targeted time, cost, ease of use, and then we've trying to package that in, maybe not in the first generation, but certainly in the second generation, which is a very much more portable unit than will be our first prototype. And then you ask availability. Availability is, we expect by fourth quarter of this year to have our prototypes in the hands of our current collaborators for the field validation. Simultaneous to doing that, there will be, for the selected assays, submissions for AOAC and the likes. So we're kind of running parallel courses here. Does that help?
Excellent summary. What I'd like to do now is allow you time to talk about your company in your closing remarks, and to let us know about this project and any other future products that would help food production managers produce safer food.
Well, a little bit about the company. The company is just slightly greater than a year old, and it was created out of a suite of technologies. We have a patent estate that we licensed from Michigan State University, certainly well known for its ag and food safety areas, and the founder of the technology, a woman, Ph.D. At the university, Dr. Elisaria, did amazing work in these nanoparticles and these types of applications. So we've licensed that technology. We've raised our first several millions of dollars of part of our Series A, and we're still working to close the second part of the Series A. And in addition to that, we've been fortunate in receiving a substantial amount of grant money from the Air Force under a DoD contract, first under a Phase 1, which has to do with detection of very difficult latent tuberculosis. I think Dr. May mentioned about the chemokine and cytokine approaches to our technology, the platform, and now we've just signed up to do a Phase 2, which is a multi-year and substantial dollar commitment. So I would say that we're better funded than most of the small companies that start these things, and we're probably better protected in our patent estate than a majority that I have done in my past, and I think that we're in a very sweet spot of a market that's rapidly changing as we go to globalization of the food. And what I didn't mention before, and we should all be well aware of, is, a decade ago you could have an event where you had a contaminant, and by the time it entered the food chain, and by the time the USDA and then the CDC got around to telling us about it, it was 5 or 6 months later. But if you think back to, for instance, the either the peanut butter issue in the Texas group, or the salmonella issue with the cantaloupes in Colorado back about 7 months ago, when it happens, it's news immediately now on the social media. So the industry, although it's very penny wise in their margins, they cannot afford to keep ignoring this issue. So I think the time is right for some new technology and some new approaches.
Excellent summary of the issues, particularly as they relate to food production managers. They are pressured in general by price constraints, and adding the additional pressure of testing prior to release without newer technologies adds additional burdens. Wouldn't you agree?
Well, we think we're at an exciting point in time, and we're very anxious to. We have some very good collaborators. We're always looking for more people that are interested in change, and people that are open-minded to it. That we can always we'd always welcome more into our validation family, but. If you really want to make something work, you have to listen to the market. And I think the market has told us that we have to tailor what we do to their needs, and we're certainly working very hard to do that.
Well, gentlemen, thank you so much for your time today. I have posted your website and contact information should any of our listeners want further information, and look forward to further developments and product launches from your organization.
I certainly appreciate that, Andy. It's been a pleasure.
Thank you, gentlemen. I'd like to wish you a great day.